welcome to Green Light Mathematics. In our class today, we want to look at trigonometric ratio. Alright, like I said, trigonometric ratio. Now, what is trigonometric ratio? This simply means the ratio involving sine of an angle, cosine, and tangent of an angle. To make a trigonometric ratio a reality, we make use of a right angle triangle. A right angle triangle is that triangle in which the sum is 90 degrees. So this is a right angle triangle, and we have to label it that the top is A. I can call this B, and I call this C. Okay, so now in my right angle triangle, the vertex of this angle, I will make it angle theta. Meaning that making this angle theta and the corresponding side of this angle is AC. That tells you AC, being one of the sides of the right angle triangle, is the opposite. We call AC side opposite. Okay, now we look at the other side, the AB and CB. Now the AB, being the longest side, is called hypotenuse. Then CB, being the last side, CB, or rather you can say BC is called adjacent. Alright, so with this, you can truly define a trigonometric ratio of an angle. So first, if I'm to define the trigonometric ratio of sin theta, since I told you that trigonometric ratio is defined as the ratio involving sine, cosine, and tangent of an angle. So if I'm to define a trigonometric ratio of sine of an angle, that means I will say that sine of angle theta will be equal to opposite, I will abbreviate it, all over hypotenuse. This is the abbreviation of hypotenuse. Okay, so now, what is opposite? Like I told you that side AC is opposite. It means that the opposite now is AC. We say over hypotenuse. What is side? Hypotenuse AB all over AB. Now, this is the trigonometric ratio of sine of angle theta. Take note. When to define the side opposite, you don't just put any side corresponding to angle theta is always opposite. It means that if this theta comes in here, maybe I happen to have something here like this. ASBC becomes opposite, while this side becomes adjacent. But the longest side, after you might have defined both the opposite and the adjacent, the longest side of right angle triangle is always hypotenuse. So take note of that. Now I need to remove this so that we can concentrate with the theta. Okay, now I define once again cosine of angle theta, which that will be equal to, now cosine is the adjacent all over, okay, let me see, make it abbreviation since you know it already. Adjacent all over hypotenuse. Take note of that. Hypotenuse. So this is equal to, what is the adjacent? Adjacent side is BC, and what is the hypotenuse is AB. Okay, so we can as well define the trigonometric ratio of tangents. Tangent of an angle theta. What is the tangent? That is opposite all over adjacent. Good. Opposite of adjacent. Now, what is opposite? From what we have here, opposite is AC all over adjacent. What is adjacent? Adjacent is BC. Okay, so this, what we have, all these expressions define trigonometric ratios of an angle. Now, there are a lot of properties of this right angle triangle which we need to take into consideration so that if question comes, we can easily solve question comfortably. Now, we are done with this. We want to introduce what we call reciprocal ratios. Reciprocal ratios. Now, look at the board. We have reciprocal ratios. Now, reciprocal ratios in the sense that each of these ratios, we can find their inverse. We can find their inverse because there are a lot of questions that will come. They ask you to get their inverse. Take for example now, inverse of anything, inverse of any variable is 1 over that variable. So inverse of sine is 1 over sine. That means as you are dealing with sine theta, it means that inverse of sine theta is 1 all over sine theta. Now what is 1 over sine theta? It is the same thing as cosec theta. The inverse of cos theta, meaning 1 over cos theta. Now 1 over cos theta is the same thing as sec theta. This cosec, they simply mean cosecant. Sec means secant. So we are using it in abbreviation form. Okay, then inverse of tan theta is cot theta. That simply means cotangent. That is 1 over tan theta. Alright, so we're going to go on a short break. When we return, we will try and make use of these ratios to see how we can solve question. So don't just go away, just get ready for the next segment. Thank you.